Hello friends, in this video we will learn how to find a signature of a given permutation. Let's see the definition of the signature of a permutation. Let A be a set containing n elements 1 to up to n and F be a permutation of set A. We have seen the topic permutation of set A in detail in previous videos. Let's see what is the definition of signature of a permutation. Then signature of this permutation F is the product of all Fi minus Fj divided by I minus j for I greater than j. Where I and j belongs to set A. You can see that here we have to take I greater than j, means if j is equal to 1, we have to take I as 2, 3, 4 up to n. If we take j is equal to 2, we have to take I as 3, 4, 5 and so on up to n. And we can take value of j up to n minus 1. Let's see some examples. If A is a set containing 4 elements 1, 2, 3, 4 and any one of the permutation of set A, suppose in the permutation F 1 maps to 2, 2 maps to 4, 3 maps to 1 and 4 maps to 3. We have seen that F is a permutation of set A. Then signature of F is equal to product of Fi minus Fj divided by I minus j for I greater than j. Here you can say that if j is equal to 1, we have to take I as 2, 3, 4. If j is equal to 2, we have to take I as 3 and 4. If j is equal to 3, we have to take I as 4. We can't take j is equal to 4. Okay. Therefore, signature of F is equal to, just take I is equal to j is equal to 1. If you take j is equal to 1, then we have choices for I as 2, 3, 4. Then we'll get f of 2 minus f of 1 divided by 2 minus 1 into f of 3 minus f of 1 divided by 3 minus 1 into f of 4 minus f of 1 divided by 4 minus 1 into f of now take j is equal to 2, then we have choices for I as 3 and 4. F of 3 minus f of 2 divided by 3 minus 1 into f of 4 minus f of 2 divided by 4 minus 2 into f of if we take j is equal to 3, we have single choice for I, that is I equal to 4 divided by 4 minus 3. Okay. Therefore, signature of f is equal to f of 2 is in the permutation f 2 maps to 4. Therefore, f of 2 is 4 minus f of 1. We have f of 1 is 2. Is here the first time we have 4 minus 2 divided by 2 minus 1, that is 1. Okay. The next we have f of 3 minus f of 1. F of 3 is 1, f of 1 is 2. So we have 1 minus 2 divided by 3 minus 1, that is 2. Third term is f of 4. F of 4 is 3, f of 1 is 2. 3 minus 2 divided by 4 minus 3, 4 minus 1, that is 3. The fourth term we have f of 3 minus f of 2. F of 3 is 1, f of 2 is 4. 1 minus 4 divided by 3 minus 1, that is 2 into. In the fifth term we have f of 4. F of 4 is 3 and f of 2 is 4. 3 minus 4 divided by 4 minus 2, that is 2 into f of 4 is 3, f of 3 is 1. 3 minus 1 divided by 4 minus 3. 3 minus 1 divided by 4 minus 3, that is 1. So it is equal to 2 divided by 1 into minus 1 divided by 2 into 1 divided by 3 into minus 3 divided by 2 into minus 1 divided by 2 into 2 divided by 1. So you can observe that some terms are cancelling. In the fifth term we have here here in the fourth term we have here 3 minus 2. Yeah. So here we have the third term, fourth term 3 minus 2. So here we have 1. Okay. Here you can see that some terms are cancelling. This 2 will cancel with this 2. This 2 will cancel with this 2. This 3 will cancel with this 3 and remains minus 1. So you can see that here we have product of -1 3 times. So signature of F is -1. Means we got signature of permutation F of a set containing 4 elements 1 2 3 4 is -1. Let's find signature of all permutations of set containing 3 elements. 3 elements 1 2 3. Then we have seen that the set of all permutations of A is denoted by the symbol S3, and it contains 6 permutations, which are rho 1 is equal to a permutation in which all elements mapped to themselves. Rho 2 is equal to a permutation in which 1 maps to 2, 2 maps to 3, 3 maps to 1. Rho 3, permutation in which 1 maps to 3, 2 maps to 1, and 3 maps to 2. Mu 1 is equal to a permutation in which 1 maps to 1, 2 maps to 3, 3 maps to 2. Mu 2 is equal to a permutation in which 2 maps to 2, 1 maps to 3, 3 maps to 2, and mu 3 is a permutation in which 3 maps to 3, 1 maps to 2, 2 maps to 1. Okay, let's find signature of all permutations of S3. Signature of rho 1. It is equal to product of all I greater than j, f of I minus f of j divided by I minus j. It is equal to, if you take j is equal to 1, we have choices for I as 2 and 3. So it is f of sorry, rho 1. So here we have tried rho 1 of I, rho 1 of j. Okay. Since in the permutation rho 1, each element maps to itself, will get I greater than j. Rho 1 of I is I, rho 1 of j is j, or you can say that, okay, we'll see it later. Rho 1 of 2 minus rho 1 of 1 divided by 2 minus 1, rho 1 of 3 minus rho 1 of 1 divided by 3 minus 2. For j is equal to, we'll get, for j is equal to 1, we'll get these two terms. Now take j is equal to 2, we'll get rho 1 of 3 minus rho 1 of 2 divided by 3 minus 2. So it is equal to, rho 1 of 2 is 2, rho 1 of 1 is 1 divided by 2 minus 1. Rho 1 of 3 is 3, rho 1 of 1 is 1 divided by 3 minus 1. Rho 1 of 3 is 3, minus rho 1 of 2 is 2 divided by 3 minus 2. See, 2 minus 1 is 1, 2 minus 1 is 1, 3 minus 1 is 2, 3 minus 1 is 2, 3 minus 1 is 1, 3 minus 1 is 1. All terms are cancelling, so we'll get 1. Therefore, we got signature of row 1 is 1. Okay. Let's find signature of row 2. Row 2 is a permutation in which 1 maps to 2, 2 maps to 3, 3 maps to 1. Therefore, signature of row 2 is equal to row 2 of 2 minus row 1 of 1 divided by 2 minus 1. Sorry, row 2 of 1. Row 2 of 3 minus row 2 of 1 divided by 3 minus 1, and row 2 of 3 minus row 2 of 2 divided by 3 minus 2. Okay. Row 2 of 2 is 3, row 2 of 1 is 2 divided by 2 minus 1, 2 minus 1 is 1. Row 2 of 3 is 1 minus row 2 of 1 is 2 divided by 2. Row 2 of 3 is 1 minus row 2 of 2 is 3 divided by 1. So it is equal to 1 by 1 minus 1 by 2 into minus 2 by 1. So these 2 will cancel with these 2 and remains minus 1. So we have in the term minus 1 2 times, so it is minus 1 raised to 2. So it is equal to 1. Therefore, we got signature of row 2 is equal to 1. Let's find signature of row 3. Row 3 is a permutation in which 1 maps to 3, 2 maps to 1, and 3 maps to 2. Therefore, signature of row 3 is equal to row 3 of 2 minus row 3 of 1 divided by 2 minus 1. Row 3 of 3 minus row 3 of 1 divided by 3 minus 1. Row 3 of 3 minus row 3 of 2 divided by 3 minus 2. Okay. Row 3 of 2 is 1 minus row 3 of 1 is 3 divided by 1. Okay. Row 3 of 3 is 2 minus row 3 of 1 is 3 divided by 2. Okay. Row 3 of 3 is 2. Row 3 of 2 is 1 divided by 1. It is minus 2 by 1 into minus 1 by 2 into 1 by 1. This 2 will cancel with this 2 and remains minus 1. Means in this product we have minus 1 2 times, so it is minus 1 square, so it is 1. Therefore, signature of row 3 is 1. Let's find signature of mu1. We have mu1 is equal to a permutation in which 1 maps to 1, 2 maps to 3, 3 maps to 2. Therefore, signature of mu1 is equal to mu1 of 2 minus mu1 of 1 divided by 2 minus 1, mu1 of 3 minus mu1 of 1 divided by 3 minus 1 into mu1 of 3 minus mu1 of 2 divided by 3 minus 2. It is equal to mu1 of 2 is 3, mu1 of 1 is 1 divided by 1, mu1 of 3 is 2, mu1 of 1 is 1 divided by 2, mu1 of 3 is 2, mu1 of 2 is 3 divided by 1. So it is 2 by 1 into 1 by 2 into minus 1 by 1. Okay, this 2 will cancel with this 2. In this product we have minus 1 only one time, so it is minus 1. Therefore signature of mu1 is minus 1. Let's find signature of mu2. Signature of mu2 is mu2 is a permutation in which 2 maps to 2, 1 maps to 3 and 3 maps to 1. Therefore signature of mu2 is equal to mu2 of 2 minus mu2 of 1 divided by 2 minus 1, mu2 of 3 minus mu2 of 1 divided by 3 minus 1, mu2 of 3 minus mu2 of 3 minus mu2 of 2 divided by 3 minus 2. So it is mu2 of 2 is 2, mu2 of 1 is 3 divided by 1, mu2 of 3 is 1 minus mu2 of 1 is 3 divided by 2, mu2 of 3 is 1, mu2 of 2 is 2 divided by 1. So it is equal to minus 1 by 1 into minus 2 by 2 into minus 1 by 1. Yes, this 2 will cancel with this 2 remains minus 1, means here we have minus 1 3 times, minus 1 raised to 3, so it is minus 1. Therefore we got signature of mu2 is minus 1. Let's find signature of mu3. Mu3 is a permutation in which 3 maps to 3, 1 maps to 2, 2 maps to 1. Therefore we will get signature of mu3 is equal to mu3 minus 2 divided by mu3 minus 2 minus mu3 minus 1 divided by 2 minus 1, mu3 of 3 minus mu3 of 1 divided by 3 minus 1, mu3 of 3 minus mu3 of 2 divided by 3 minus 1. So it is equal to 1 minus 2 divided by 1, 3 minus 2 divided by 2, 3 minus 1 divided by 2. So it is equal to minus 1 by 1 into 1 by 2 into here we have 3 minus 2. 3 minus 2 is 1. Okay. 2 by 1. This 2 will cancel with this 2 and remains minus 1 one time. So signature of mu3 is 1. Means here we have determined signature of all elements of S3. We got signature of row 1, row 2, row 3, 1, and signatures of mu1, mu2, mu3 minus 1. Let's see some properties of signatures. Note that let A be a set containing n elements and F be any permutation of a set A, means F is any element of Sn, then signature of F is either 1 or minus 1. The signature of any permutation is either 1 or minus 1. Okay. Let second note, let A be a set containing n elements 1 to n and F and G are any two elements of Sn, means F and G are any two permutations of a set A, then signature of F composition G. We have seen how to find composition of two permutations in previous videos. Okay. And signature of F composition G is nothing but product of signature of F and signature of permutation G. This is very important result of a permutation. Okay. Let's see note number 3. Let A be a set containing n elements and F be a transposition of set A. Transposition means a cycle of length 2. Then signature of F is minus 1. One can prove it easily. Means signature of any transposition is always minus 1. Fourth point, let A be a set containing n elements 1 to n and F be a permutation of this set A such that f is written as product of k transpositions, product of k transpositions, then signature of f is equal to, see by third note, signature of any transposition is -1, and second note says that signature of f composition G is equal to signature of f into signature of G. By combining node 2 and node 3, we can write signature of f as -1 into -1 -1 k times. Therefore, we will get -1 k. Means if you have a permutation, we can write it as a product of k transposition, then signature of that permutation is -1 k. Note 5. Let A be a set containing n elements and F be an even permutation of A. Even permutation of A. We have seen definition of even permutation. Even permutation means a permutation we can write product of even number of transpositions. Therefore, we can write signature of A, signature of F is equal to -1 k for some even k. Because FBA permutation we can write even number of transpositions, and if f can be written as k number of transposition, then signature of f is -1 k, and in this case f can be written as even number of transposition for some even positive integer k. Okay. Therefore, signature of f we can write -1 k for some even positive integer k, and therefore signature of f is 1. Similarly, f be an odd permutation of A, then signature of f is equal to -1 k for some odd positive integer k. Because odd permutation is a permutation, we can write it as a product of odd number of transpositions. So it is -1. Means note 6 says that signature of any odd permutation is -1, and note 5 says that signature of any even permutation is always 1. Note 7. Let A be a set containing n elements 1 to n and F be an identity permutation of A, then the signature of A is 1 as any identity permutation, as identity permutation is even permutation, as identity permutation is always even permutation. Or by definition you can write, signature of F, or by definition you can write signature of F is equal to product of Fi minus F of j divided by I minus j for I greater than j. Since F is identity permutation, Fi maps to I, Fj maps to j, so it will be I to j, I minus j divided by I minus j, because Fi is I, Fj is j, so these two term will cancel and we'll get set of all I greater than j into 1 of 1, means it is product of 1 1 1, so it is equal to 1. Therefore signature of identity permutation is always 1. And let's see a last note. Let A be a set containing n elements 1 to n, and A be any permutation of A, then signature of F inverse is equal to signature of F. Signature of F inverse is equal to signature of F. Okay. Since F is composition of F and its inverse is identity matrix, identity permutation, identity permutation of A signature of F composition F inverse is equal to 1, since signature of identity permutation is always 1. And we have seen that signature of F composition F inverse is equal to signature of F into signature of F inverse. Now case 1. We know that signature of any permutation is either 1 or minus 1. Case 1, signature of F is equal to 1. Then 1 into signature of F inverse is equal to 1, and therefore signature of F inverse is also 1. Means if signature of F is 1, signature of F inverse is also 1. And case 2, signature of F is equal to minus 1. Then minus 1 into signature of F inverse is equal to 1, and therefore multiply both sides by minus 1, you will get signature of F inverse is equal to minus 1, and hence signature of F inverse is equal to signature of F by case 1 and case 2. Note 8 says that if F is even permutation, its inverse is also even permutation. If F is odd permutation, its inverse is also odd permutation. Because signature of F is 1 if and only if F is even permutation, and signature of F is -1 if and only if F is odd permutation. Okay, now I am stopping the video. Thanks for the watching.